We want to determine the antiderivative. We have the integral of 4 cosine square root x dx. This integral appears in the integration by parts section. It doesn't appear like an integral that requires integration by parts, but it actually does. But before we perform integration by parts, we need to perform substitution. Because the integration by parts formula uses u and v, let's perform substitution using w. We will let w equal the inner function of the square root of x, which we know is equal to x to the power of 1/2. Next, we determine dw, which equals the derivative of x to the power of 1/2 times dx, which is 1/2 x to the power of 1/2 minus 1, which is x to the power of negative 1/2 times dx. Now, this doesn't look helpful at all because we don't have a factor of 1/2 as well as a factor of x to the power of negative 1/2 as part of the integral. So what we'll do is we'll go ahead and solve for dx. To do this, we will multiply both sides by 2 x to the power of positive 1/2. This gives us 2 x to the power of positive 1/2 dw equals, on the right side, 1/2 times 2 is 1. X to the power of negative 1/2 times x to the power of positive 1/2 is x to the 0, which is also 1. The right side is now just dx. But notice on the left side we have an x as well as dw. This isn't helpful, but remember, x to the 1/2, or the square root of x, is equal to w, and therefore we can perform another substitution and write the left side as 2w dw equals dx. Again, we simply substituted x to the 1/2 with w. And now let's perform the substitution. The given integral equals the integral of 4 times cosine w, and then again dx equals 2w dw. Let's go ahead and simplify this and write this as the integral of 8w times cosine w dw, which now looks more like an integral that requires integration by parts. Let's go ahead and clear the information from our substitution, except we do need to remember that w equals the square root of x, or x to the 1/2. So we'll clear all this information and set up integration by parts. We will let u equal 8w, and therefore dv equals cosine w dw. And now du equals the derivative of 8w with respect to w times dw, which is 8 dw. And v equals the integral of cosine w dw, which is sine w plus c, for now just sine w. And now I'll perform integration by parts. The integral of 8w cosine w dw equals u times v, which is 8w sine w, minus the integral of v du, which is 8 sine w dw, and the integral of 8 sine w dw equals negative 8 cosine w plus c, giving us 8w sine w minus negative 8 cosine w plus c. Of course, subtracting a negative is equivalent to adding a positive, giving us 8w sine w plus 8 cosine w plus c. Be careful here, we're not done. For the original integral, we were integrating with respect to x, not w. We now need to replace w with either the square root of x or x to the 1/2. Using w equals the square root of x, the final antiderivative is 8 times the square root of x times the sine of the square root of x plus 8 cosine of the square root of x plus c. I hope you found this helpful.